All right, so slopes of lines. This is objective 3-4. The slope is the ratio of the vertical change, which we often refer to, we often refer to it as the y's, to the horizontal change, which we often refer to as the x's, between any 2 points of a line. So slope is rise over run, or y sub 2 subtract y sub 1 divided by x sub 2 subtract x sub 1. So this is the difference in the y values divided by the difference in the x values. And same thing that you had to do in Algebra 1. If you're going to use this formula, you have to memorize it. So this should mostly be review. We're going to use the slope formula to determine the slope of each line and count the rise and run. So I'm going to do the first two examples by using the formula. Well, actually, I'm going to do all 4 of these with using the formula. So the first thing I'm going to do is make a little list over here of what my points are. So A looks like it is -2, 7. Let me double check that. B is 3, 7. C is 4, 2. And point D is -2, 1. All right. So remember, it's always X and then Y. So A, from A to B. All right, so my X's and my Y's. So what comes on top? That's right, Y's. So 7 minus 7. And -2 subtract 3. This is going to give me a 0 over a -5. And I want to remember that the slope would be 0. AC, -2, 7. And what's C? 4, 2. So same thing, X and Y's is going to be 7 subtract 2. -2 subtract 4. We're going to end up with 5 over a -6. 3. A is -2, 7. And D is -2, 1. So here I'm going to have 7 subtract 1 over -2 subtract a -2. Those become a positive, and I end up with 6 over 0. When you try to divide by 0, what happens? Right, the world collapses. That's a black hole. So this is undefined. And then now, I'm just cranking out these slope values. And C is 4 over 2. All right, so we have 1 subtract 2, and then we have -2 subtract 4. So we end up with a -1 over a -6, and 2 negatives make a positive. All right, so I used the formula, and I plugged and chugged. So I got the answers 0 for example 1. And if I look at the example 1, line AB, there's line AB, and I hope you remember that horizontal lines have a slope of 0. The Z's go together. All right, example 2, I plug and chugged, and I got 5 over -6. So let's now look at line AC. AC kind of looks like it's going downhill. You guys probably remember Slope Dude and how he would go downhill and the slope would be negative. And so if I wanted to count this slope on the graph, I want to get from point A to point C. So I would go 1, 2, 3, 4, 5 down. And 1, 2, 3, 4, 5, 6. So I would go down 5 and over 6, and that would give me that negative. That would be the same thing as that 5 over a negative 6. All right, and let's visually check line AD. So AD is right here. So AD was undefined. So if you remember Slope Dude, this is when he cussed because he fell off the cliff and he yelled out, undefined. And by the way, I'll put the link in for Slope Dude so you guys who haven't seen it can go back and enjoy it in all of its wonderful glory. Last example. Where's my slope? Right here. 1/6. So we're looking at line DC. DC is just slightly going uphill. And if we wanted to go from D to C, we would go up 1, and then we would go over 1, 2, 3, 4, 5, 6. And that would be 1 over 6. So hopefully that was just a quick review of all things slope that you learned in Algebra 1. So if we wanted to compare the different slopes of lines, the first thing we have here is positive slope. Positive slope we can refer to as being uphill, increasing, or being on an incline. Our next topic, negative slope. Negative slope we often refer to as going downhill, decreasing, or being on a decline. Zero slope. Zero slope is a horizontal. Only the x's change. And the little Q down here, horizontal, 0. All right, that's how you remember horizontal is 0 slope. And lastly, let's use the orange. We have an undefined slope. That's when you have a vertical line and the y's are the only thing that changes. So in this example, we're going to be using the slope formula to find the slope of the line that passes through the points given. Now, I do not have a Desmos trick for you. Unfortunately, I don't have one for this case. This X right here is a little typo. Let's mark that out. However, I can show you how you can use Desmos to figure these problems out. So let's type in our problem here. I'm going to type in -2, 4. So -2, 4. All right, and I'm going to label it. And then I'm going to type in my next point, 1, -3. Oh, 3, and I'm going to label it. And so what I want you to see here is if I start at this -2, 4, and I want to get down to 1, -3, I can use my graph. If I've got my graph on a 1-to-1 ratio, I can use my graph to count. And so I'm going to go 1, 2, 3, 4, 5, 6, 7 down. So I went 7 down. And now I'm going to go 1, 2, 3 to the right. So if I go 7 down, that would be a -7 over 3. And so if I graph these points, plot the points, and then count the squares, then that will let me use my calculator and I don't have to use that formula. You use whichever one you like, whichever one you'd prefer. Doesn't matter. You just got to be able to figure out what the slope is. All right. So here's problem 7. If I'm going, so from this one, it doesn't really matter which way you're going to go. I always stop with the one at the top. So I'm going to go down 1, 2, 3, 4. So 4 down. And 1, 2, 3, 4 over. Now, what does 4, so that would be a negative 4 over 4. What does that simplify to? Right, a negative 1. So you remember you got to simplify your fractions. All right, the next one. The next two I'm just going to do the formula for, so for those of you who like seeing formulas, you can see this worked out again. So y minus y over x minus x. Some of your algebra teachers may have used the 2's and the 1's. Oh, that's going to get messy. I'm not going to write my 2's and my 1's because that's going to get messy. All right, x, y, x, y. So if I'm going from this one to this one, negative 3 subtract 3, then I'm going to go this way. Negative 1 subtract 1. So that's going to be a negative 6 and a negative 2. And negative 6 over negative 2 simplifies to a positive 3. And same thing for the last one. Oh, I just did that last one backwards, guys. So don't make my mistake. Let's redo this one. That wasn't right at all. I need to put my y's on top. So now, negative 2, negative 6. So now when I simplify, that's going to be a 1/3. If you don't remember how to simplify your fractions, you can use Desmos to simplify your fractions for you. 2, negative 6. So I want to take that away there and put the negative there. And then that little button right there on the side where it's got the 2 squares, click it, and that's how I get the 1/3. Okay? All right, last one. So we're going this way. And then that way. So this is a big old 0 on the bottom. So this slope is undefined. Okay? Now, I didn't even fool with the top. It ain't going to matter. If you're worried about it, there it is. It's negative 10, but it doesn't matter. All right, so slope-intercept form of a line. Y equals mx plus b. B is where you begin. M is how you move. This should all be algebra review. When you start graphing lines, you want to plot your y-intercept first. It's a B. That's where you begin your line. Then you count your rise over your run to plot your second point. So M is your slope and M is how you move. So if I want to graph, first of all, my slope is -3/1 and my y-intercept is at 2. So you would go to 2 on your graph and you would go down 3 and over 1. So 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And then you would draw a line. All right, that would be my line. And my slope is -3. Okay, remembering that? Now this one was pretty easy because it was given to us in this y equals mx plus b form. Sometimes though, it's not given to us in that form. So you've got two options. You can rewrite this. All right, and this is where I'm going to move stuff around. I cannot combine this 2x and this 6 because this 6 does not have an x with it. And then I'm going to divide, and I'm left with y equals 2/6 minus 6/6. Simplify my fraction, that's going to give me a 1/3 minus 1. So for this problem, my slope is 1/3. If I had to graph it, I would start at -1. I would go up 1 and over 3. Up 1 and over 3. Okay? You want to remember that if up and to the right is true, down and to the left is true. And then I could make my line. Now, if you struggle with being able to write this, let me erase this. If you struggle with being able to rewrite these equations, you can use Desmos. Type in what you're originally given. So in that case, I'm going to be typing in this. Desmos doesn't care what it looks like when you type it in. It will understand how to graph it however it looks. Okay? So now, is that pretty much what I got? Yeah. So now I can use the graph to count slope. I start at the y-intercept. I start where it goes across the y-axis, and I want to move to the next point that I see. So I'm going to go up 1. So I'm going up 1, and then 1, 2, 3, and then over 3. And you see that's going to be 1/3, which is the same thing as I got when I wrote this out by hand. That's all I got for you today, girls and boys.